Next, we're going to be hearing from Dr. Diana Bauer, and I would like to get the introduction ready for her. Hello, Diana. Just a moment. Want to give people a little bit of background. I'm excited to be introducing you because I'm learning more recently about the whole set of programs that you oversee and the interaction with both user facilities and other realms of the federal government that will be of interest to our network. Dr. Diana Bauer is the Deputy Director of the U.S. Department of Energy's Advanced Materials and Manufacturing Technologies Office, a great acronym of AMMTO, AMMTO. Dr. Bauer helps lead the strategic direction and execution of AMMTO's funding to advance energy-related materials and manufacturing technologies. Before joining AMMTO, Diana directed the Office of Energy Systems Integration Analysis within the DOE's Office of Policy, and she was the lead author of the Water Energy Nexus Challenges and Opportunities report, and she led the drafting of the Department of Energy's Critical Minerals Strategy reports. Before coming to the Department of Energy, Diana led the Extramural Sustainability Research Program at the Environmental Protection Agency, which focused on green engineering, green chemistry, green buildings, and transportation systems. She has a PhD in mechanical engineering with a concentration in green design and manufacturing from University of California, Berkeley, where many of our members are currently and have connections to. So Diana, welcome. Thank you. Over to you.
Great. Thanks so much, Dan. And it's really my pleasure to be here to talk to you. This is an audience that we're not used to talking to, so it's great to have the opportunity to do so. Give me a moment while I set up my sharing of the.
Okay. And I'll step back and I'll come in at the other side of your presentation.
Excellent. Okay. I really would like to thank everyone for inviting me, and particularly Dan Powers. We had some great conversations as we kind of figured out what was going to be in this presentation. I will say that AMMTO is just a year old, roughly this week. It's a year old, and so we're still trying to find ourselves, user facilities, test beds, and incubators are really going to be an important part of our identity. So it's a great moment to talk to all of you, to give, to sort of get a sense of whether there's a possibility to collaborate moving forward. I hope so. I think there really is. We have these facilities, these test beds, incubators, to help us accelerate the scale up of innovative manufacturing technologies to deliver America's energy future. In some cases, these facilities, test beds, and incubators are linked to manufacturing of a specific energy technology. In other cases, they are platform technologies that apply more broadly across technologies. So I'm going to start and give sort of a background, like a 50,000-foot thumbnail of AMMTO, because I figure some of you are not familiar with AMMTO. And then I'll talk a little bit about, kind of a cross-section of some of our connections to user facilities. I feel like this is kind of a contrast to the last presentation, because we're users of user facilities as opposed to funders of user facilities. So we don't have the big bucks like the last presentation. So as I'm sure all of you know, there's been, manufacturing is at the heart of America's economy. It's how we make products that enable our modern life, and advances in manufacturing are really a fundamental need to advance our ambitious energy agenda. And, over the last couple of years, we've had some really big investments in manufacturing and related infrastructure, including through the Inflation Reduction Act, Bipartisan Infrastructure Law, and CHIPS and Science Act. And this is really giving us an opportunity to, come close, if not actually delve into industrial policy for the nation. So it's actually quite a moment to engage on thinking about the future of manufacturing, and then also the future of energy. And, of course, it's important for GDP, it's important for workforce. So AMMTO finds itself at the intersection between transforming energy and transforming manufacturing. So we're really thinking about change, about accelerating change, whether that is accelerating scale up of manufacturing processes, or really kind of envisioning how we will build or enable, develop the technologies that lead to a dramatic scale up of manufacture of a lot of the technologies that are needed for the future energy economy, whether it's batteries or wind turbines or semiconductors, power electronics. So, I think advanced materials and manufacturing are really important to help us meet this moment. And we do have collectively have the tools or the dollars, at least for now, to help us meet the moment. And I think from the AMMTO perspective, we're really thinking about trying to sort of launch or help to accelerate this clean energy agenda. And we also see it as an opportunity to really strengthen the nation's manufacturing sector. It's like a challenge, like a stress test for our manufacturing sector. And you can emerge from a stress test stronger or weaker. So we want to try to help to strengthen the manufacturing sector through producing all these energy technologies. So here's our vision and mission. Basically, you can see that our vision is aligned with our unique role in manufacturing, and it bridges between a competitive manufacturing sector and a clean, decarbonized economy. And then in our mission, we put people first, and we want to include leadership and innovation everywhere. The types of changes that we need will not be brought about by our investment alone. So collaborating is really important. And building a strong competitive manufacturing sector that meets the moment to deliver the materials and technologies that are needed to address climate change, and really will benefit from the vision, insight, curiosity, and passion of everyone that we partner with. So just here's some, sort of high level themes that are throughout our portfolio. As our mission indicates, people are central to manufacturing and its future. So we have, we're focused on people in different ways, including diversity, equity and inclusion, innovation ecosystems, which are essentially communities of people, networks of people who, because of their connections with one another, they're able to accelerate the advance of technologies. And then education and workforce development, of course, is very important. Having the people is having the workforce is very important to deliver the manufactured goods, and having a workforce that is well engaged and has good paying jobs, that's valuable to the communities and society. So I mentioned innovation ecosystems. This is kind of a graphic that shows how we think about them. We have industry, academia, government, national labs, communities, all kind of coming together in this innovation ecosystem to accelerate, catalyze through convening to improve, sort of advanced technologies, data, knowledge, and kind of train the workforce. So here is our sub-program structure. So just to give you a flavor of the topics we focused on. So in next generation materials and processes, we have advanced manufacturing processes and systems, focusing on technologies like additive manufacturing, also digital manufacturing, including high performance computing and smart manufacturing, high performance materials, including high conductivity materials, materials for harsh service conditions. And then in secure and sustainable materials, we have circular economy. So, improving, accelerating recycling and reducing embedded energy through those efforts. Critical materials, so those are materials like, rare earths or lithium that are used in, various energy technologies that are subject to supply risks. Just in many cases, just because of the ramp up in demand due to clean energy. In the energy, technology, manufacturing, and workforce pillar, we have energy storage, energy conversion and storage manufacturing. So that includes batteries of different flavors, ranging from lithium ion to flow, lithium metal, etc. For semiconductors, we have work in power electronics. We also have work in highly efficient microelectronics. And then we have some cross-cutting work in entrepreneurship, industrial ecosystems, and the workforce development. So in terms of where we fit in the broader landscape of DOE, we are we're focusing on this chart is showing the innovation pipeline from early stage R&D to at scale deployment. As I mentioned, we're a new office, and we're focused on applied R&D through to early stage demonstration. So I think of us as almost the bridge between Office of Science and it used to be just the private sector, but now we have additional offices that focus on large scale demonstration and acceleration of commercialization. So OSED and MESC, the Manufacturing and Energy Supply Chain Office, as well as the Loan Program Office, those all focus at the larger scale, the kind of scale up of the innovations that we work on. So we're just in the last couple of years, the department has kind of populated this full innovation pipeline, and that gives us the opportunity to really focus on accelerating the path from innovation to commercialization. And of course, user facilities are really kind of a linchpin for doing that, is a really important tool that we can capitalize in order to do that acceleration. So we have a number of, and I don't know, I'm using the term user facilities fairly broadly. I'm not sure if what I'm calling user facilities fully corresponds to what you all consider user facilities, but we'll go with it. So our user facilities we have a collection of them, and currently include world-leading facilities for additive manufacturing, as well as we use, so that the additive manufacturing one is one that we support. We utilize the high performance computing facilities supported by the Office of Science. We also have, well, I mean, just the point, that I just made, these user facilities, test beds, also incubators can help scale manufacturing innovations so they can be commercialized. And these facilities that I'm about to talk about are really just essentially a foundation. And as a young office, just a year old, we're looking to build on this foundation to have more impact. And particularly since we have that whole innovation pipeline that I just talked about, we're actively trying to think about how we can have potentially more test beds and user facilities to really help with this acceleration of that kind of from applied research to pilot scale demonstration. So we in AMMTO have a number of consortia, and these consortia in many cases sort of form a home for some user facilities and test beds. So I'll be talking about some of these in the subsequent slides. So, these consortia address topics ranging from composites, and this is IACME, to power electronics, which is Power America, to additive manufacturing, which is the Manufacturing Demonstration Facility, or MDF. So, and then these consortia are also important kind of assembly points for innovation ecosystem. So that's also, the sort of networks of people and organizations that are important to accelerate this innovation. So I'm just going to go through some of these just to give you a flavor of the range of ways that we kind of interface with facilities, test beds, and incubators. So MDF, this is about the Manufacturing Demonstration Facility at Oak Ridge National Lab, and MDF is perhaps our best known user facility, and its purpose is to develop additive manufacturing and composite technologies for clean energy applications and aid in their adoption by small, medium, and large scale industries within the US. It's a large-scale open access facility for rapidly demonstrating early stage R&D manufacturing technologies, including manufacturing equipment and optimizing critical processes. And while we are the principal supporter, the facility has drawn significant additional investment from other DOE offices and also from DOD. It's a great touch point for the manufacturing community, bringing over 200 industry partners and thousands of visiting researchers over the years. And so it's a core of an innovation ecosystem. So here's another one. Also, this one is affiliated with the IACME, the Composites Institute. It was established, as a partner between IACME and NREL, and it is responsible for, it brings in researchers to design, prototype, validate, and manufacture composite wind and marine turbine blades and other components. And it also has a complementary computational modeling capability to characterize prototype structural properties. So this XFAB is affiliated with our consortium, Power America, focused on power electronics. It's not affiliated with a DOE national lab. It is focused on production of silicon carbide wide bandgap power electronics. And the initial pilot line was established to validate the concept of running silicon wafers on silicon carbide wafers on a silicon fab. And being able to do this accelerated the timeline for the development of this new line by 2 years, and also led to hundreds of jobs. And Power America members developed multiple additional wide bandgap power electronics fabrication processes at the same foundry. So this is essentially a user facility that helps manufacturers of these power electronics kind of test out their lines. So it was quite timely and successful. We also have sort of interface at perhaps a smaller scale with the national lab facilities. When we do this through lab calls that bring in CRADAs. So in this case, we through our lab call, we support individual projects that capitalize on facilities within labs, and then bring in industry to collaborate. So we have individual projects that do that. And we just issued a lab call or a couple of lab calls in the past year, and we have some new projects starting up there. And I will say that in the battery space, one of the things we're thinking about is whether there are opportunities to also pursue platform technologies that might apply across multiple chemistries to help to scale things up kind of more broadly, more effectively. We also, as I mentioned earlier, we have high performance computing facilities that we have a program that competitively supports industry to develop projects in collaboration with several national labs, high performance computing. So we have projects supported in this ranging from computational modeling of cost-effective carbon capture technologies to model-based bending tests for high-strength automotive aluminum sheet alloys. So we have quite a range of different projects supported through this activity. And currently the program is specifically focusing on trying to attract more small and medium-sized businesses. And then finally, the facilities are also useful for developing people, obviously. And this is a program that we lead that supports entrepreneurs. So the Lab Embedded Entrepreneurship Program embeds entrepreneurs in their early stage startups at one of 4 national labs and facilitates mentorship with a lab scientist. And a particular focus of LEAP includes direct embedded access within national lab user facilities for the entrepreneurs to develop and refine their startup technologies on site. So this is a program that really kind of captures the imagination of a lot of people. It's started a lot of businesses with, as you can see there, significant follow-on funding. So I'm coming to a close on my talk here. Just in summary, user facilities can help us innovate and validate new materials and manufacturing technologies. These facilities are equally important for the training and development of innovators that will help America's clean energy future. And finally, we're enthusiastic to collaborate with all of you to strengthen and scale up manufacturing to reach our nation's clean energy goals. And that's it. Thanks very much.
First, as you and I have only known each other for about, I don't know, a month and a half now since learning about the program, I was curious if you could speak a bit more to the example that you gave regarding the connection with the Advanced Materials Laboratory. I didn't jot down the name, at Oak Ridge.
Oh, right.
Just as maybe describe that a little bit more of the kind of projects that are happening there. And then a second question I had, you had referenced how AMMTO supports CRADAs with some of the different national labs. When you say support, maybe this is a shorter answer, does that mean you provide the funding for the given CRADA, or what does support mean in that context?
Yeah. So we support the CRADA as part of a larger project. So we'll support time for for the national lab researcher. Like it's part of a proposal for a project.
Right.
But just the point is that we're trying to build the connection between the national lab people and capabilities and facilities and industry.
Okay.
Yeah.
Thanks. And actually, there's a project I want to speak to you about afterwards that a company approached us to ask how they could work with the National Renewable Energy Lab.
Perfect.
But then back to that Oak Ridge example.
Yeah. So we have it's a lot of additive manufacturing. 3D printing. And they've had some pretty what shall I say, like compelling sort of headline grabbing kinds of things. Like they've additively printed housing. They've additively printed a car that's now in the DOE reception area. And then they also have some pretty fundamentals of additive manufacturing, like improve processes to improve performance characteristics of additive manufactured components, a lot of spatially varying properties, producing materials with spatially varying properties, merging together the digital side with the sort of additive manufacturing processes, and then they have some inline analytics to be able to characterize properties as while production is occurring. So they have like the fundamentals that then lead to applications including they make molds for cast parts. They make motors. They print a bunch of like a wide range of technologies.
Right. And then how might you suggest? Imagine there's a mix within our audience, and we'll be looking to share this video as well with additional members and stakeholders who weren't able to be here live today. From the given user facilities perspective, what more do you think they should know about AMMTO? And I'm thinking down particularly to user administrators, the people who work with, similar to if you had heard Kevin, my introduction of Kevin Fournier. So he's looking to interact and help make that connection between the outside academic or private sector technologists with what the lab has. How do you?
So what I would suggest is if there's enough people who are interested, in sort of having more of a conversation, it might be worth arranging kind of a roundtable discussion just to kind of get to know you. so that we can understand what capabilities are there that we're not, aren't sort of part of our current landscape. And maybe on your side, you all can help us think through our sort of vision of platform technologies to help with manufacturing. Or maybe there's some other way of thinking about ways of accelerating scale up of manufacturing that we're not thinking about. And certainly things like analytics, or sort of kind of characterization of material properties, particularly if we can do it in line. Those kinds of things are potentially interesting. So it might be good to just have a brainstorming session if there's enough interest.
Okay, I think we will. There's actually, and I have a couple particular contacts in mind.
Okay.
So thank you. I also put in the chat, as I had been learning more about AMMTO's programming, a link from the Department of Energy site, specifically describing the project and activity with Oak Ridge.
Yeah, that's great.
People who are looking at this right now can get that link.
Yeah, and I will say that
follow up with some further outreach to understand how AMMTO can be a resource to help build those bridges. And the LEAP program, we're familiar with the LEAP program as well. That is a really compelling and fast moving, showing a lot of actual
it's a very exciting program. And I will say that I think if folks are interested in hearing more about MDF, we can definitely set up like a totally dedicated meeting on that as well.
Okay. Great. All right. Well, then thanks for giving us this first impression from many people of what your program is working on. And we will look to be a connector and make some direct connections for you with some of these users who are interested in, as they get to know more of what AMMTO is doing, especially in this decarbonization type of realm or next energy paradigm realm.
Yeah, I think it's a great opportunity, and as I say, we're new, so we're still finding ourselves. So that's a great moment to try and influence us.
Okay. All right. Well, thank you very much again, Diana, and we will be having some more follow-up.
Thanks to all of you.